All right, let's take a look at these problems. We wanted to square all these numbers, so 1 squared is 1, square root of 1 is 1. 2 squared is 4, square root of 4 is 2. 3 squared is 9, and so on. So we have 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. That's what the perfect square numbers are. Next, we're going to take square roots of these three things. Just going to type it in my calculator. Square root of 64 is 8. Square root of 1/9 is 1/3. Square root of 0.64 is 0.8. And I can't do the square root of negative 25 because it's negative. So it has no square roots. Now what we're going to talk about is reduced radical form. We need to simplify. So if we simplify, we should have no perfect squares divide into the radicand and no more pairs of numbers. And we'll see that in a second. No fractions inside the radical. Can't have a fraction inside the radical. We can deal with that later as well. No radical in the denominator. If there's no radical in the denominator, then you're good to go there. We'll look at that a little bit later down the road. So let's jump in, simplify 50. We factor tree. And once you break it down, I suggest getting rid of the number. That way you don't think that you still have it. There's no 10, it's 5 and 2 now. So we have a pair of 5s and 1 2 left over. So the pair of 5s come out as 1 5. We're looking for square roots of or pairs. 2 doesn't have a pair, it stays inside by itself. Another way to think about this would be 25, root 25 times root 2. Root 25 is 5, and that's just 5 times root 2. So we'll break this down to 64 and 10. That's 2 and 5, 8 and 8. All right, so once we break it down, scribble out, we have one pair of 2s, another pair of 2s, another pair of 2s, but we still have 5 left in there. So 2 times 2 times 2 is 8 root 5. 4 root 20, so we have a number out front. We just keep that for now. And it's 20 we need to break down. So 4 and 5, 2 and 2. So we have a pair of 2s. I bring out a 2. I don't have a pair for 5, so 5 stays in there. And then I multiply everything out. The 4 that was originally there and our 2 that we took out because of the pair give us 8. And square root of 5 just follows. It's weird we have the same answer for B and C, but it happens. 160. So we already have a negative 5. Break this into 10 and 16. 2 and 5. 4 and 4. 2 and 2. So I have one pair of 2s. Another pair of 2s. But I still have a 2 and a 5 left over. So those stay inside. Multiply everything outside together and everything inside together. So negative 5 times 2 times 2. Negative 20. 2 times 5 on the inside is 10. Negative 20 root 10. 294. I don't know what big numbers go into it, but I know that 2 goes into it because it's an even number. So we have 8 already. I break down 294 into 2 and 147. 147 can be broken down into 3 and 49. 49, 7, and 7. I have a pair of 7s, but I have a 2 and a 3 left over. So I multiply the stuff on the outside, multiply the stuff on the inside. All right, same for letter F. We just kind of keep the 3 there ready to use it. 900, 30, 30, So we could see right now that we're going to take out 30 because we have a pair. So I'm going to keep going, but we can see that there's a pattern there already, or a pair. So 2 times 3, 2 times 3, we have a pair of 2s, a pair of 3s, and a pair of 5s. So we would bring out 2 times 3, 5, which is 30. No leftovers, so nothing in there. So I just multiply the 3 and the 30, get 90. Letter H, we need to add these first. So 15 plus 10 is 25. We know the square root of 25 is 5. We could also look at it as a factor tree. We have a pair of 5s, that's one pair. We bring out the 5 and nothing left over. The next one, I, we could multiply these together, but then we have to break it down anyways. So we'll just keep it there. We'll break them both down. Basically what that's doing. So it's 2 and 60, 3 and 10. 60 is 4 and 15. We get 2 and 2 and 3 and 5. We break the 10 down a little bit more. So what do I have pairs of? I have 1, 2. So bringing that out. I have another 2. I have a pair of 5s. And I even have a pair of 3s. Nothing left over, so the radical's gone. 2 times 2 times 5 times 3 is 60. So we're just looking for pairs. That's all we're doing with square roots. Now reduce in radical form. If you have a fraction under the radical, you reduce the fraction first and then simplify the radicals like we just did. Switch up the color. No, I'm not. So the square, we can't simplify 9 over 49. Nothing goes into 9 and 49. So I split them up. Square root of 9 is 3. Square root of 49 is 7. 4 over 25. Nothing goes into 4 and 25. So I split them up. Square root of 4 is 2. Square root of 25 is 5. Letter C. 18 over 32. Now we can divide by something. We can divide by 2. So it's 9 over 16. Nothing else will divide in, so we split them up. And we get square root of 9 is 3, square root of 16 is 4. Letter D, again, we can divide by 2. We end up with 5 over 81. We split that up. Square root of 5 we can't do, so we're just going to leave it alone. Square root of 81 is 9. Now, does it break any of our rules? No, because the radical is not in the denominator. The fraction isn't in the radical, just 5 is. And 5 is simplified. We have no more pairs. So we got that one done. Lastly, we need to be able to go backwards. So I have a 3 on the outside and a 10 inside. What was the original problem? When we bring that 3 back in, it becomes 2 because we're looking for pairs when we take them out. Now I'm putting it back in and making a pair. So 10 times 3 times 3 is 90. So same thing with this one, 15, and then a pair of 2s, which gives me 60. And the last one, 6 and 5 times 5. And that pair goes with that. So we multiply together, we get 150. And that's how you simplify radicals.